Next up, a University of Nebraska-Lincoln survey of 1,200 irrigation water samples from 85 of 93 Nebraska counties were analyzed for several nutrients in the 60s. This survey has been largely forgotten and since hasn't been systematically replicated. Yet this data is getting a second look from UNL Professor of Soil and Water Sciences, Dr. Charles Wortmann, and is yielding some new perspectives on the testing and quality of irrigation water. Market Journal's Bill Dodd has more.
Thanks, Troy. Now, how interesting is that? A survey from the 60s could have a current impact on testing irrigation water quality now. Now, while the information that this study provides is broadly generalized and far too old to be utilized in any sort of fertilizer use commitment, it does still demonstrate the value of testing each source used for irrigation.
Review back and forth until we're finally convinced that it's good, solid information, every sentence.
According to UNL Professor of Soil and Water Sciences, Charles Wortmann, crediting some of the nitrate applied in nitrogen water for determination of fertilizer nitrogen rates has long been advised in Nebraska. However, nutrients applied through irrigation have not often been directly credited in fertilizer use decisions, although some may have been credited through the interpretation of soil test results. So, while the original survey may need some updating, it's still providing qualitative information.
So I've been aware of this for a long time, but generally I think this study has been forgotten. And because it was done in the 1960s, it does point for a need for renewal of this study. But we just took the data and we reported the averages and minimum maximum values encountered in summary, and then mapped it out, of course, by county. So the data is there in the data set by county, but it's not georeferenced, so we can't go to the exact wells and say where it was from.
So why exactly should you care about a survey done in the 60s on wells we can't individually identify? Well, that's easy to answer. The test results showed statistics for nutrient concentration in an amount applied per acre foot of irrigation water and estimated nutrient removal in 250 bushels per acre corn grain harvest. To boil it all down, the key nutrients your crop needs to thrive may already be readily available in the irrigation water you're providing them, which means you may be applying more nutrients than the crop will remove from the soil. In other words, you may be leaving some money on the ground.
Well, it's an opportunity to save quite a bit of money. And so we get quite a bit of potassium in the irrigation water, for instance. And, it might help the producer to understand why aren't my soil test K values dropping more than they are. Sulfur, most wells have an abundance of sulfur. You apply in a season, on average, more than a crop removes in 250 bushel of grain. Also with calcium, magnesium, boron, you might be putting on more with irrigation water than you would be removing in a 250 bushel harvest. For other nutrients like phosphorus, we don't get very much. But there's a lot of variability in results within counties and across counties. And so to really know what you have, you want to test your own wells.
So now you may be thinking it's probably a good idea to test my water source and see if there are any reductions I can make in my fertilizing decisions. If that is the case and you're ready to get the ball rolling on testing your irrigation source, Charles has some tips to get the most accurate results. The first of which is, if your water is coming from a well, be sure to pump the water from the source first, preferably at the peak of irrigation season.
Well, the concentration could change some with time. If you haven't pumped recently, that water right near the, you're right in the borehole might have somehow a different concentration. So to avoid that and get a more representative sample, we suggest pumping for 24 hours, beforehand. So you're well into a cycle of irrigation, you grab your sample.
On the other hand, if your water is coming from a surface water source, the location of the water is paramount. You should always remember to take samples from below the surface.
Again, it should be when irrigation is going on, the water is flowing, and et cetera, et cetera. And because if there's some contamination is there from dust or this sort of thing, it's going to be more on the surface than underneath, floating. So grab it from beneath the surface for surface waters, such as with canals.
When you are ready to collect a sample, Charles recommends rinsing your container often in order to eliminate as much chance of contamination as possible.
Well, because the concentrations are really quite low, so if you have any contamination, it can really affect the results. Now, I would encourage you to get the sampling bottles from a laboratory, and I'm guessing that they'll be coming to you sealed, and with the lid on, etc. They should be quite clean. But even so, rinse it and just use the well water there, because you're using the same water to submit. So rinse it once or twice and then catch your sample.
Now, one final tip Charles shared with me when it comes to testing your irrigation water pertained to sample sizes. Charles tells me about 10 ounces of water are needed for a full analysis, and you'll want to confirm this with the laboratory you'll be working with. Furthermore, when working with a lab, it's also suggested to request an entire suite of essential nutrients to be tested for. If you do end up testing your irrigation source, Charles would like to know what you find, and he encourages you to share your results, including the latitude and longitude of the tested area, in order to update the information and build a more current database on the subject. You can reach out to Charles via email at cwortmann2@unl.edu or by phone at 402-472-2909. And Troy, that's what I've got my eye on this week. Sending it back to you.